Chapter 1, so we're going to be coming upon a test soon. And so first of all, when we talk about inverse relations and functions, we're going to talk about what an example of a relation is. Okay? Right there is an example of a relation. Okay, and so then now what we're going to do is we're going to look at that relation graphically. Okay? And then we're going to talk about the inverse relation. So what I want you to do right now, okay, is I want you to focus on two things. I want you to focus on Table A and Table B. And I want you to tell me what you notice between Table A and Table B. And also I want you to look at this table and this table and tell me what you notice. So I'm going to give you about 30 seconds right now to look at those. So Table A, Table B, what do you notice? And then the circles around those two relations. And I want you to tell me what you notice. Okay? Got about 10 seconds left. Okay, what do you notice between Table A and Table B? They're the same numbers, but they are flip-flopped. Right? The position is switched. So then I want you to look at these two relations that I have here. Y equals x squared minus 4 and then x equals y squared minus 4. What do you notice? The numbers are the same, but they are flipped again. So basically the x column here corresponds to the y column here. And the y column here corresponds to the x column here, and that's not a coincidence. If that occurs, these are called inverse functions. They're inverses of each other. And so today we're going to look at how you can visually determine if they're inverses, and then we're also going to look at how you can determine if they're algebraic inverses. Now let's look real quick at the graph. Okay, the graph of x squared minus 4 is in blue. Notice that is a parabola. It opens up. Okay. X equals y squared minus 4, that's the green graph. And so if you notice they've got a red line drawn in there. Y equals x. We remember what function that's called? Parent function? Y equals x? The identity function. Okay. Now one of the things about the identity function is that if I were to fold the blue graph over the red line, so imagine I take my paper and I fold it over. That will give me the green graph. Okay? So if I take it over that red line, if I just fold my paper, this blue will be the green graph. And vice versa, it works both ways. So that's the thing about inverse functions. They actually are reflected along that red line. So let's go ahead and talk about inverse functions and some of the characteristics that they have to follow. First of all, a function will only have an inverse if and only if it passes the horizontal line test. Okay, so remember we had a vertical line test with a function. If it has an inverse, it has to pass the horizontal line test, which basically means if I take a horizontal line and I move it up through the graph, it can only touch the graph at one point. If it touches at more than one point, it doesn't have an inverse. Okay? So, yeah. I know. That was just an example. I know. I understand what you were going to say. Okay, so let's go ahead and look at this one. It says graph each function and apply the horizontal line test to determine whether its inverse function exists. So I want you to graph that first one. F of x equals the absolute value of x minus 1. Now, some of you might not need to graph it because you could remember what this function looks like and tell me right away what it will be. What type of graph is this? Absolute value. So what's an absolute value always look like? A V. So is that going to pass the horizontal line test? No, it's not, because any point along there, it's going to intersect twice. So there's the graph you're looking at. If I draw any line in here, it's going to intersect twice right here and here. Now that doesn't mean we can't find an inverse. What we actually do is we restrict the domain so that we only look at a portion of the graph. And so what we'll do is we could find an inverse, but we would have to take the inverse from this point to the right. Okay, because if you only look at the graph from this point to the right, it would pass the horizontal line test. So basically it's called restricting the domain. So there is a way to do that. Let's graph the second one. X cubed minus 6x squared plus 12x minus 8. Okay? Good window to view that in is the z-decimal window. Okay, z-decimal actually works very, very well. What does that graph look like? Where does it intersect the x-axis? Where does it intersect the x? Okay, you should be able to visualize at where? 2, good. Okay, so it intersects at 2. Graph looks something like this. Okay, I know it looks like it at the axis it does something like this. Okay, it actually doesn't flatten out, and so this in fact would pass the horizontal line test. Okay, so that's just kind of one of those things to know. That's what the graph of a cubic function would look like. So this one would in fact have an inverse function. So now we're going to talk a little bit about what a one-to-one function is. Okay, first of all, a one-to-one function is a function that does pass the horizontal line test. It means that no x value is matched with more than one y value, and no y value is matched with more than one x value. I'll let you get those down and then we'll go ahead and talk a little bit more about that. Okay, so we know a function is one-to-one if it passes the horizontal line test. This statement in purple is pretty important because this is exactly what a one-to-one function is. No x value is matched with more than one y value. So that means for every x, there's exactly one y value. And also, no y value is matched with more than one x value. Okay? So that means if you had a chart like this, you had an xy chart right here, and I've got the point -1, 4, 0, 5. Nothing else could have the 4, nothing else could have the 5. Okay, so that y value of 4 and 5 could only be paired with one x value. So it's kind of like, if you think about that, a couple. Okay? You only have one couple, you can't be paired with anybody else. It's just two people. All right? Okay, has an inverse function, so every one-to-one function will have an inverse function because it does pass the horizontal line test. Also, the domain of f equals the range of the inverse. Now notice this is the terminology for an inverse function. It's f with a little -1. Okay, that means the inverse, so f inverse. And so what this says is that the domain of the function will equal the range of the inverse. And that should make sense because we looked at those columns, right? Those columns flip-flopped. The range of f equals the domain of the inverse. So, How we find an inverse function. This is the steps taken from your book. I don't know if you necessarily need to write these down because we're going to go through these in our next example. Okay, and so I'm going to write the steps as we go through step by step, but just so that you know it is in your book and you can follow through. And they in fact have exactly the same steps we're going to go through. This is on page 66. So if you get stuck, you can always go there and look. But it says determine whether f of x has an inverse function. If it does, find the inverse and state any restrictions on its domain. So the very first step you got to do is you got to graph it. And you got to see if this function passes the horizontal line test. Okay? So that is the very first step. So very first step. Does it pass the horizontal line test? So that's the very first step. Does it pass the horizontal line test? So if I graph this one, it looks like z decimal doesn't work. And it looks like z standard doesn't work. I'm actually going to change my window so that it goes all the way down to -20 on the y. Okay. So keep your x's the same, just change your y min to -20. So do you see what the graph looks like now? Does it pass the horizontal line test, yes or no? It doesn't? This is what I got the graph to look like. Okay, and I know it looks like it kind of levels out right here. It actually does keep going up. So this, in fact, does pass the horizontal line test. So it does, in fact, have an inverse. Okay. Step 2. You're going to replace f of x with y. That's all you're going to do. Okay, that's step 2. Step 3. You're going to now switch x and y. So where I see y, I'm going to put x. Where I see x, I'm going to put y. Oh, to the third, sorry. I forgot. Well, it had a power. There we go. We'll change them to the third. There, that's a little better. Okay? All right, so then now your next step is going to be to solve for y. So we need to get y all by itself. So what's the first thing I'm going to do to solve that for y? Add 16, very good. So I'm going to add 16 to both sides. So I end up getting x plus 16 equals y cubed. How do I undo that cubed, or that power of 3? The cube root, okay? It's actually the cube root here where I'm going to put a little 3 right there. And I'm going to do that to both sides. So really, when I solve, I end up getting the cube root of x plus 16 equals y. Okay, so then the final step is going to be to replace y with f inverse, that notation. And now I need to state any restrictions on the domain. So I need to think, are there any values of x that will not work on this one? Are there any values of x that will not work? Because could I take the cube root of a negative number? Yeah, I can. Because I can take the cube root of -1 and I'll get -1 as my answer. And so this is going to be your inverse function. Now we're going to go through another one just in case you didn't quite get that. Okay, here we go. So first step, doesn't pass. Okay, so does it pass the horizontal line test? Yep. Now, just a little tidbit. What do you notice is the domain of this function? What's the domain of that function? It goes from 4 to infinity, okay? So that's just kind of just a little tidbit. I'm just going to kind of make that note for myself. What's the range in that function? 0 to infinity. Once again, I'm just going to kind of make some side notes because the reason why I didn't do that on the problem before, if you're wondering, is because the problem before was all real numbers for both. See, this one only has part of the graph. I mean, it doesn't include everything. So now, step 2. Step 2, I replace f of x with what? Y. So I get y to equal root x minus 4. What's the next step? Switch them. So x equals root y minus 4. What do I do now? Yep, so how do I do that? What's the very first thing I do? Square it. Good. Perfect. So I'm going to square both sides. So I end up getting x squared equals y minus 4. Yep, add 4 to both sides. So I end up getting x squared to equal, oh, never mind, x squared plus 4 equals y. And then what's my next step going to be? Remember, you got to write it as an inverse. Okay. Now, this is where we need to go back up to what I have written up here. If you remember the very last step, I need to state any restrictions on the domain. Okay? The domain of the inverse is the same as what up here in purple? The range. Okay? So what I need to do is take this and I need to pop it down here. Okay, so the domain of this will be from 0 to infinity. Okay, those need to match. And like I said, the reason why we didn't do it on the problem before is the problem before was all reals. So we don't have to worry when it's all reals. Okay, but that's the restrictions on the domain that we're talking about. So they're saying that that graph only works for the inverse between 0 to infinity. Questions? Okay, this one. Let's go ahead and graph this. I think we have, yep, this is it. Okay, with that one. Very first thing you need to do is what? Graph it. Does it pass the H line? Okay, now let's go ahead and write, what's the domain of this graph? Negative infinity to what? What x value? Negative 2, okay? And then from negative 2 to infinity, because it can't be negative 2, right? Because at negative 2 there's like a graph, or a break in the graph. What's the range going to be here? So it starts at negative infinity, right? Where does it have the break horizontally? At 1, yep. And from 1 to infinity. So now we got to go through the steps. Step 1, y equals x minus 1 over x plus 2. What's step 2? Yeah. This is where things get a little interesting. Now you're going to want to pay attention because you're going to see one of these in the future. Okay. Now the question is, how do you solve that for y? This is what we need to do. First of all, that fraction's killing us. So I'm going to get rid of the fraction. So I'm going to multiply by y plus 2 on both sides. So on the left side, when you multiply that by x, what do you get? xy plus 2x, good. And that's going to equal what? Y minus 1, right? Because the y plus 2's cancel. So then now we have to solve it for y. So in order to solve for y, I want to get everything with y on one side. Everything else goes on the other side. So do you want to move the y over, or do you want to move the xy over? What? The y, okay. So if I move the y over here, that's going to now be partnered up. Then I also have to move the 2x over here. So on the left side, what are you left with? xy minus y, right? That's what you're left with. You can't combine those. What are you left with over here on the right? Negative 2x minus 1. Good. Now, in order to get rid of that y, you need to factor that y out. Okay, so if I factor that y out, I get x minus 1. So if I take that, how do I solve that for y now? Divide by x minus 1, exactly right. Okay, I've got to divide that by x minus 1. And so my new equation for my inverse will be negative 2x minus 1. So y equals, and you could change that, divided by x minus 1. So what we can do, and I can do it a little bit easier than you, is I'm going to just change that so that it says f inverse. Now remember, we have some restrictions on our domain here, right? So here's my inverse, but what's my domain here going to be the same as? The range up above. So this is going to be my domain down here. So negative infinity to 1 and 1 to infinity. And there you go. Okay. I'm actually going to stop right there today. I'm not going to go through the rest of the lesson. We're going to call that good, which means we'll probably push back a day, but that's okay. We'll continue with composition of inverse functions tomorrow. So if you want to go ahead and get a start on your homework, I need you to do that, okay? Now tomorrow I am picking up sections 1.5 and 1.6. Have them done and ready to go, okay? But this assignment right here will be due Wednesday. We'll finish it tomorrow. Probably have that short quiz tomorrow as well. Remember the apparent functions. Make sure you know all the 8 graphs. Tomorrow's Wednesday. Okay, so well, this assignment will be due Thursday then. So.